Hello guys, in this video we will be discussing about finding the derivative of a trigo function using chain rule. Now if you could recall from the definition of a chain rule, we have here the expression y is equal to u of x raised to the power of n. Now take note, our u of x here is any function raised to the power of an exponent of n. Now our u of x, if you are going to relate that from the given function, our u of x is the one inside the parenthesis, which is 1 plus cosine of 3x squared. And our n value is an exponent 5. Now in finding the derivative denoted as y prime, all you have to do is to bring your exponent down, so that will become n. And then all you have to do is to copy the function inside the parentheses, subtract 1 from your exponent, that will become n minus 1, and multiply that with the derivative of our u function denoted as u prime. This is the derivative inside the parentheses, u of x. This is now the process that we're going to follow in answering our trigonometric function using the chain rule, because basically this one follows from this expression. So we have to follow the definition. Now in finding the derivative of this function, all we have to do is to write y prime, or shall I say dy over dx, the derivative of y. Then all you have to do is to bring down 5. If you're going to base that from our definition, bring that down. So that's why we have here n, which is this point that's equal to 5. Then copy the function inside. So we have 1 plus cosine 3x squared. So this is our n value. Our u of x is the one inside the parentheses, and we copied that. And what is n minus 1? It means to say that we are going to have 5 minus 1. And then multiplying that with the derivative of our u of x. At this point, what is our u of x? This is our u of x. This is the one which is our u function, and we're going to get the derivative of the u, denoted as u prime. So basically, we are going to use sum rule, because this is first term and the second term separated by addition operation. Now, what is the derivative of 1? Okay, that is actually 0. So if you will try to write that in a separate sheet of paper, our u of x, which is the one inside the parentheses, is actually 1 plus cosine 3x squared. So copy that. This is now 1 plus cosine 3x squared. Now, by using u prime of x, meaning the derivative of u, the one inside the parentheses, what is the derivative of 1? That is 0. Plus, what is the derivative of cosine 3x squared? If you could recall the derivative of a trigo function, you have here the derivative with respect to x. If you have here cos u, the derivative is just negative sine u times u prime. Now, if you will try to base that from our cos 3x squared, so we have here cos 3x squared. This is our cos. Our u function is equal to 3x squared. Meaning to say, in finding this derivative, all you have to do is to what? All we have to do is to copy the same formula. So copy negative. So we have here negative, and then copy your sign because that is coming from here. But what is your u? Take note, your u is the one inside the cosine or beside the cosine. So we have here 3x squared, copy. So we have here 3x squared times, what is the derivative of the u? Or shall I say u prime? The derivative of this is 6x. This is constant times a function. So we have here times 6x. In short, the derivative of cosine 3x squared, which is the second term, is equivalent to negative sine 3x squared times 6x. So copy, you have here negative sine the quantity 3x squared and then times 6x. So we can erase this one. So the derivative of 1 is 0. The derivative of the second term cos 3x squared is negative sine 3x squared times 6x. Simplifying our u prime of x, 0, that is just nothing. Negative times 6x is equivalent to negative 6x. And then copying sine, and then copy 3x squared. Now, negative 6x cannot be multiplied to 3x squared because 3x squared is actually belongs to sine. So you cannot multiply negative 6x and 3x squared. So this is now our derivative for our u, the one inside the parentheses. So this is now the value that we're going to multiply with. So this is now times, continuation here, negative 6x. We have here sine 3x squared. Take note, this is actually x variable and this is x variable. Now multiplying 5 to this function, so we are going to multiply simple functions, and you cannot distribute 5 to this function because this is protected by an exponent of 4. So this is now y prime. What is 5 times negative 6? That's negative 30. Copy the variable x and then copy sine 3x squared. And then all you have to do is to follow the function 1 plus cos 3x squared raised to the power of 4, which is the complicated function. So 1 plus cos 3x squared raised to the power of 4. 4 is actually from 5 minus 1. So this is now our derivative of the function. Another example, if we have here tan x to the 4 raised to the power of 2. Now take note, this is a trigonometric function. Okay, tan x to the 4th raised to the power of 2. So this one will follow from this format. Our u of x is the one inside the parentheses. Our u of x and our exponent n is equal to 2. So in answering and finding the derivative, all we have to do is to follow the same definition. So bring your exponent down. So we have here y prime is equal to 2. And then all we have to do is to copy the function inside the parentheses. So we have here tan x to the 4. And then by following this, you have to subtract 1 from your exponent, which is 2 minus 1. And then multiplying that with the derivative of the u of x. Now what is our u of x? The one inside the parentheses. So you can actually copy that from the separate sheet of paper. So our u of x is equal to tan x raised to the power of 4. Now in finding this derivative denoted as u prime of x, then we have to recall the derivative of trigonometric function involving tan. Now what is the derivative with respect to x of tan u? Now this is being read as a derivative of tan u with respect to x. Now take note, tan x to the 4 is actually given. This is our u of x. And how to find the derivative of that function with respect to x? Now we have here tan, and our u is actually equivalent to x to the 4. Now what is the formula in finding the derivative of tan u? The formula is equal to the secant squared u times the u prime. Meaning to say, in finding the derivative of tan x to the 4, all you have to do is to copy the same. So we have secant squared, and then all you have to do is to copy u. What is your u? X to the 4th. X to the 4th times the derivative of your u. Again, what is your u? X to the 4th. According to power rule, we are going to find the derivative of x to the 4 as 4x cubed. So in short, the derivative of tan x to the 4th is just equal to secant squared. What is your u? That's x to the 4th times the derivative of your u, which is 4x cubed. This is now our derivative for the tan. Copy that here. So we have following or copying first the simple function 4x cubed, and then will be followed by the complicated function secant squared x to the 4th. Take note that secant squared x to the 4th is actually inside secant squared. And this could be written as this way. You can do that. So let me erase this. So if we're going to base that from our line here, our n value is equal to 2. Tan x squared to the 4th is actually the one inside the parentheses. Copy that here according to our process. N minus 1 or 2 minus 1, and then multiply with the derivative of the u, or the one inside the parentheses. What is the derivative? 4x cubed times secant squared of x to the 4th. So times, copy, you have here 4x cubed secant squared x to the 4. Now you can simplify 2 and 4x cubed. So in simplifying, this is now equal to 8x cubed. And then you can follow tan. What is tan? We have here tan x to the 4th. 2 minus 1 is still 1. So this is understandable that we have an exponent of 1. But you can just write that way. That's possible. Anyway, tan x to the 4th to the 1 is still tan x to the 4. And you can actually enclose that by a parenthesis. And then followed secant squared of x to the 4. This is now our derivative.